Hello students, this video is about binary search tree and operations on binary search tree. Binary search tree is a data structure that quickly allows us to maintain a sorted list of numbers. In fact, it follows the properties such as all the nodes of the left subtree are less than the root node, all the nodes of the right subtree are more than the root node, and both left and right subtrees. Into this, each node or whatever trees we have, that are also BSTs. That is, they also follow the properties that BST follows. Since it's a binary tree, we'll take a structure of node where we'll take this int data for keeping the actual value, and we'll have a left pointer as well as a right pointer. Here I have implemented various operations on this binary search tree, such as creating a tree, inserting an element into the tree, pre-order, in-order and post-order traversal, finding the smallest element, largest element, and deleting an element from BST, finding out the total number of nodes, how many external nodes are there, internal nodes of there, finding out the height of the tree, and as well as deleting BST. So if you go on with the node, I've just taken a do while loop for printing out the menu, and then I'm taking an option into a switch case where I'll be implementing various operations on BST. Let's go ahead with creation of a tree. While creating a tree, initially we'll have a pointer or a tree which will be assigned as a null value. We'll have an insert element function inside create tree. Here we have taken a pointer, node pointer, and a parent pointer which will be pointing towards the parent. Now here, whenever a tree has to be created, the first thing is we'll be creating different nodes. So this is nothing but we are allocating a size for a particular node, allocating a memory. We have taken a pointer variable for this. Okay, then into data we will be actually placing the values, and initially whenever a new node is created, its left and right pointer would be null. Now if there is no node in the tree, then we'll be assigning this to a tree and we'll be assigning left and right pointers as null. Now if there are certain elements into the tree, we'll be comparing it with the values of the node pointer and as well as the parent pointer, and accordingly if the value is lesser than it, we'll be placing it into the left node, and if the value is greater than it, then we'll be placing it into the right node. And that is how we'll be inserting every node into BST such that property of BST is to be followed. This is pre-order traversal function. Into pre-order traversal, we know that the root node will be, or the parent node will be traversed first, then the left part, and then the right part. So we are just printing the value at the root node or the parent node, then we are going for left part, and then we are going for right part, as it says VLR. When it is in order traversal, it is LVR. So for that, again we are going in the same way. The only thing is just order will be changed. So in case of in order, we'll be going for left nodes first, then the root nodes or the parent nodes, and then the right part. In case of post order, we'll go in LRV order, and this order is being followed. Similarly, here is the function return to find out the smallest element into the binary search tree. Okay, so we are just comparing the values over here, and we are finding out the smallest element. As we know, the smallest element would be present into the left part. So we are just traversing the left part over here and trying to find out the smallest element. Similarly, we know that the largest element would exist at the right side. So we'll be implementing the function at the right side only. And there are different other functions are also allocated. Let's run this program. When we actually run this program, the first option is being entered for inserting a node into the binary search tree. So it's asking the value for the new node. Let's say it is 65, which will be our root node. Then again I'm trying to insert some more nodes. Let's say it's 45, and then again I'm inserting a new node. Let's say it's 80. So I've inserted total 3 nodes. Okay, let's check the options. So for pre-order I have option 2. So let's go for option 2, and my output would be displayed. Okay, so this is the pre-order. So root is given first, and then we have left part, and then we have right part. So like this, all the others functions of BST can be also implemented. Thank you for watching.